Let's work example 1. This one says, the directions say, each of the following sequences is either arithmetic or geometric. Identify the sequences and list the next 3 terms for each. Okay, so let's make sure that we know what we're doing. So each one of these next few, we have A, B, C, and D. Each one of these examples is going to be either arithmetic or geometric, so we have to tell what they are. And then it says to list the next 3 terms for each one. So we need to go 3 more. Okay, so what I want you to do is you've listened to the introduction video. We've learned a little bit about arithmetic and geometric sequences. So what I want you to do is, in just a minute when I tell you to, pause the video, and I want you to try and look at each of these 4 examples and see if you can figure out if they are arithmetic or geometric, and then go ahead and write out the next 3 terms. When you're done with that, come back and push play on the video, and we'll see if you're correct. So go ahead and pause now. Alright, so hopefully you did what I told you to, and you had some time to look and think at these examples. And so now let's see if you're right. So for part A, we have 1, 5, 9, and 13. It looks to me like each one of these is adding the same amount to get from term to term to term. It looks like we're adding 4 each time, doesn't it? So since we're adding the same amount, that makes it an arithmetic sequence. And since it's arithmetic, then that means we would continue to add 4 to find the next few terms. So if I add 4 more, that would be 17, and then 21, and then 25, and then so on and so forth. So hopefully you did that one correct. The next one, to get from 70 to 120, we would have to add, what, 50? And then to get from 120 to 170, we'd have to add 50 more. So we are adding the same amount. It can't be different. It has to be adding the same amount each time. So that makes this an arithmetic sequence. And if we were to keep adding 50, that would make our next few terms 220, 270, 320, and so on and so forth. All right, so hopefully you did the first 2 correctly. Let's see how you did on the second 2. We have 1, 3, 9, dot, dot, dot. So what did you figure out is happening to get from one term to the next to the next? It looks to me like we are multiplying by 3 to get from one term to the next, which makes that a geometric sequence. And if we were to keep multiplying by 3, then our next few terms would be 27, 81, and then 243, dot, 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 on and on and on forever. Now the last one might have been a little bit tricky because we're using those exponents, but what are we really multiplying by to get from one term to the next, to the next, to the next? Well, if you remember your exponent rules, remember that when you multiply like bases, you actually add the exponents. So what we're multiplying by here is 10 to the second, because 10 to the first times 10 to the second, you would add the exponents to get 10 to the third. and then multiplying 10 to the third times 10 to the second, you're multiplying like basis, so you would add the exponents to get 10 to the fifth, and so on and so on and so forth. So that actually again makes this a geometric sequence. And if we were to keep multiplying by 10 to the second power, we would end up with 10 to the ninth, 10 to the 11th, and then 10 to the 13th. Because when you're multiplying those bases, you always add the exponents. So I hope you did well on that example.